Greetings from Amera Astronomy Center and Jordan Planetarium at the University of Maine. My name is Sean Lotch. I'm the Planetarium Director, and I look forward to sharing some of the beauty and wonder of our universe with you. This is our virtual sky tour for the week of June 26th through July 2nd, and we're going to be taking a look at our current night sky with stars, constellations, and planets. We'll also take a look at Antares and some of the latest discoveries around it using the National Radio Astronomical Observatory, and take a look at how we measure distances to stars. How do we know how far away stars are? Well, let's find out. And lastly, we'll talk about our upcoming online star party through our astronomy club, the Universe Explorers of Maine. Well, let's go ahead and get started. We're going to begin tonight with our night sky, sort of changing things up a little bit. So give me one moment as I switch over into our program that we call Stellarium, which is the one we use to look at our nighttime sky. And we're going to set up Stellarium for this evening with the sky around roughly 9:45 p.m. in the evening, facing the direction west. Now with this, we're going to be seeing the moon to begin with. And the moon is right now a waxing crescent phase in our evening sky. And it is going to reach first quarter phase on Sunday evening. So between now and then is a really great time to look at the moon with binoculars or a small telescope, as you'll be able to see the mountains, valleys, and craters sort of jump out a little bit. It's easier to see the moon that way when it is a little bit less illuminated. Once it gets past first quarter phase, there's a lot of extra light that is reflecting back to Earth, and it can actually sort of make those craters and mountains disappear a little bit. So again, I really recommend looking at the moon before first quarter phase to really get the best view of it with binoculars or a small telescope. Well, the moon can help you find the constellation of Leo the Lion, one of the spring leftovers, which is slowly but surely sinking into our western sky. The star Regulus marks its heart. A backwards question mark is the head and mane of the lion. And then this triangle right above the moon tonight is going to represent its hindquarters. Now, to me, I must admit, the lion looks more like a mouse with a curly-Q tail, and if we draw it in, that's how it would be. But again, the Greeks imagined a majestic lion who had fought a battle with Hercules. Well, again, you only have a couple weeks left to see it because it is one of the spring constellations, and we are rapidly moving in to the season of summer. Alrighty, well, coming back to this view of our sky, we're going to do a couple things. We're going to zoom out a little bit here, and then we're going to head high overhead until we get a few other things visible in our night sky. So right now, high overhead from Leo and sort of heading back towards the northwestern area of the sky, if you will, we can find the constellation of Ursa Major, the Great Bear. And most folks see it as the Little Dipper, which is just that asterism, that small portion of it. These 7 stars through here, which look like a pot or pan. You can draw a line through the first 2 out the open end, and they point you to the North Star, which is at the end of the handle of the Little Dipper here. And the Big Dipper part of Ursa Major, that Great Bear, if we highlight one of the stars in it, we can draw in the stick figure of that bear, which would look something like this. Now, the Great Bear or the Big Dipper can help you find some other things in our sky. In fact, if we use the stars in the handle of the Big Dipper, we can draw an arc to the bright star called Arcturus, which is in Boötes, that herdsman or bear chaser, right up through there. It looks kind of like an ice cream cone. And after arcing to Arcturus, we can spike to Spica in Virgo. And Virgo is sort of a Y-shaped group of stars through there. Well, Arcturus is about 37 light years away. We're going to be talking a little bit about star distances tonight. We'll start off with Arcturus, which is an orangish star, about 37 light years away. Well, let's mark that star there in our night sky, and we can then draw in Boötes the herdsman, and we'll also mark Spica here in our night sky and see the constellation of Virgo. And with lots of imagination, we could draw in, again, Virgo, the maiden or goddess of fertility, Boötes, that herdsman chasing away the great bear there in the nighttime sky. Well, coming back to our view of the sky here, what we were going to do now is shift around once again, and we're going to move our sky over until we are facing the direction of south. And so here we're facing south now, and I'm going to put time into motion a little bit here because I want to speed things up and move ahead from 9:45 to about 11 p.m. at night. Now, as we're doing this, you're going to notice a couple things happening. Stars are going to be drifting across our sky there from east to west. And around 10:30 in the evening, Jupiter and Saturn are going to rise over in the southeastern sky. And if you have binoculars, you can easily see the moons that Galileo discovered around Jupiter: Io, Ganymede, Callisto, and Europa. They look like little pinpoints of light. You would need a telescope to see Saturn's rings. And I urge you to take part in our upcoming online star parties again in July. We'll tell you a little bit more about them at the end of the session, as you'll have a chance to look at Jupiter and Saturn through the virtual eyepiece of SLU telescopes and see them up close. Now, we're talking about stars, of course, primarily tonight, and stellar distances. And one of the stars that is very prominent in our summer skies is Antares. In fact, it's sometimes called the jewel of the summer season. That is a red supergiant star in the constellation of Scorpius. This is the head of the scorpion up here. Here is its tail all the way around to its stinger, marked by the star Shaula. Now, if we highlight one of the stars in Scorpius, we can draw it in. It has also been called Kamakau Nui o Maui, or Maui's fishhook, by the Hawaiians. Lots of different cultures saw different things in the sky. Well, the Greeks saw it as a scorpion who had stung Orion, that poisonous arachnid, if you will, and as it did so, Orion crushed it with his club. So Diana placed Orion in the winter skies and the scorpion in the summer one. Well, the scorpion there, quite visible, and we're going to be learning a bit more about the star Antares a bit later. Now, if you find the scorpion, right next to it in the sky is a teapot-shaped group of stars, and that is Sagittarius, the teapot, right through there. And that teapot is kind of nice to spot because if you see it as a teapot, you can watch the steam of that teapot rising up overhead, sort of right through that area, up through there. So right off the spout of the teapot is the center of our Milky Way galaxy. And again, take a look with binoculars if you have them. It'll reveal lots of stars in this area of the sky. Well, we're going to follow that Milky Way on up. And as we do so, we're going to move high overhead here until we can see the summer triangle. So follow that Milky Way on up again. And as we do so, it will take you all the way up to the summer triangle made up of the stars Vega, Deneb, and Altair. Now, we've been talking about these a lot lately, so tonight we're just going to talk about their distances. Vega is 26 light years distant from the Earth. That means it takes light 26 years from that star to reach us on Earth. If it blinked out tomorrow by some reason or chance, we wouldn't know about it for 26 years. Altair takes 16 years for that light to reach us. It means it's 16 light years away. And Deneb is 1,600 light years away. Now, if you look at these three stars, they're close in brightness, particular Deneb and Altair, but they're at much different distances, of course. Altair is at 16 light years, and Deneb is 1,600, almost 100 times farther away. So, what do we know about this? Well, we can't tell the distance of a star just by looking at it, because stars come in different sizes and have different brightnesses. But there are ways of finding out the distances to the stars. Let's move back to our PowerPoint. We'll check out Antares, and we'll find out a bit about how we measure distances to those stars. Well, it'll take me just a moment here to switch our gears and shift back over to our PowerPoint. And so here we are back with our PowerPoint once again. And as I mentioned, we're going to start off by talking a little bit about the star Antares. Now, Antares is this star that we know of and have watched over time. It is a reddish star in the constellation of Scorpius. And here is a little video clip from NRAO about this. Now, Antares is a supergiant star, much larger than our sun. In fact, if you could drop that star where our sun is, its photosphere, or visible surface, would stretch out to about the orbit of Jupiter or so. Well, the National Radio Astronomical Observatory has been using two of its telescopes, ALMA and the VLA, to explore again, this star, in great detail, and it was able to measure some interesting new things about it. First off, we actually were able to measure its atmosphere, or again, the corona of this star, and it stretches about 12 times farther out than the actual photosphere. So that means it is a really, really huge star, and beyond that, we were able to measure its stellar wind and how that expands into space. Now, here on Earth, the sun gives off its own stellar wind, which causes our auroras. If we lived around Antares, we would have exceptional auroras because that wind is much more powerful. Well, we've learned a lot about Antares over time, and this star is a red supergiant. Most likely it will die in a supernova explosion far into the future. Again, ALMA and the VLBA have given us some really good insights into this red star that is in the heart of Scorpius the Scorpion. Well, we mentioned that Antares is 600 light years away, but how do we know that? Well, we can measure distances to stars, and we've talked about some of these stars already tonight. Arcturus, 37 light years away. Antares, 604 light years away. And again, Vega, Deneb, and Altair. Well, how do we measure distances to stars? Well, that is something that we use a method called parallax to do. And to do that, it is a little bit challenging at times, but we do want to take a look at how we can measure parallax there in our sky. And what we'd like to do with that is take a look at stellar parallax and a little video about that as well. And so here is a little video clip that I'm going to play from you from the Las Cumbres Observatory that talks about stellar parallax.
Have you ever traveled down a road in a car and looked at the mountains or hills in the distance? If you have, you've probably noticed that while nearby trees quickly fly past the window, the mountains move much slower, and in the far distance, the moon and the stars don't seem to move at all. As you move, objects closer to you, such as the trees, seems to shift position relative to more distant objects, like the mountains. This effect is called parallax. The size of this shift depends on the distance you travel along the road and how far away the trees are. The closer they are to the road, the bigger the shift. The same thing happens as the Earth moves around the Sun. Over the course of a year, some stars appear to move a very small amount relative to other stars. Like the trees along the side of the road, these stars are just closer than those that don't seem to move. Actually, all stars are moving through space, but much more slowly than parallax, so we don't notice. Now, if we measure how much a star moves when the Earth does one complete trip around the Sun, we can use this to work out this angle, called the parallax angle. If we observe a star when the Earth is at one spot in its orbit, and then wait 6 months for the Earth to move around the Sun to the opposite point along its orbit and observe the star again, we can measure the parallax angle. Since we already know the distance from the Earth to the Sun, we can now use this parallax angle and some trigonometry to work out exactly how far away the star is. This is really useful because it allows us to calculate the distance to nearby stars very accurately. This can then be used to check the distance measured by different methods to even more distant objects out in space.
Well, I hope you enjoyed that little video. It's a great little description of how we measure distances to stars. So by looking at that parallax angle, we can determine the distances to stars. Now again, it is very tiny and it does require special telescopes to do, but it is pretty amazing that we can use the position of the Earth and looking at positions of stars over time and how they shift just slightly to measure the distance to these stellar objects, these stars and many other objects in space as well. Well, the last thing on our list for tonight is to talk a little bit about the Universe Explorers Club of Maine. This is this online astronomy club that we launched this last month, and we're going to be having our inaugural star parties for the group on July 10th and 24th. You do need to be a member of SLU to be able to join our star party and look virtually through the eyepiece. We're going to be checking out Jupiter and Saturn. We're also going to look at a variety of deep sky objects and get a chance to learn all about them, and you'll have a chance to do that too. And SLU provides you a way to take your own images of the night sky. You can observe live, but you also can snap pictures using Thlu's robotic telescope. So I urge you to join the club and join us on July 10th and 24th. Now, information about the Star Party is going to be posted in the club discussion area, and it will be conducted via Zoom. So it'll be a really great way to take a look through the telescopes, and I'll also be doing another guided tour of a variety of these objects in the night sky. Well, I hope you've enjoyed our virtual sky tour and little astronomy update here this week. Do keep looking up and enjoy the beautiful summer weather. Get out there and look at the wonders of Maine's night sky. Have a great week.